Kepler was a German astrologist and mathematician who proposed the three laws of Kepler, which describe the way orbits of the planets work in our solar system. Kepler was able to get his conclusions through the work of his collaborator Tycho Brahe. Brahe, who also was a physicist and a mathematician, registered the orbits of Mars. But he didn't share his work until he died because he had fear that this one would be taken by another person and published.
Johannes Kepler took advantage of all the teachings of Copernicus, together with a great interest in finding how planets moved around the Sun. After many years of study, he could discover that these did not move in circles, but they do in elliptical form. That means like in an oval. His deep studies allowed him to formulate the three laws of movement of the planets, which currently serve as the basis of astronomy. In this video, we will see a brief explanation of the second law formulated by Kepler that shows the elliptical orbits that describe the planets.
So basically, what my friend Ian said, he said that Kepler was a very important scientist, and it's totally correct. The law that we're talking about right now is the Kepler's second law. It states that a line between the Sun and the planets sweep equal areas in equal times. This because the speed of the planet increases as it nears the Sun and it decreases as it recedes from the Sun. Assuming that we can know that the time is a very important value and it's sometimes is equal, the area will be equal if the time is equal because of the velocities of the planet. So if the time is equal, it doesn't matter if the Earth is on a perihelion or an aphelion, because if the time is equal, the area of the values be the same. Here we have an image.
So, for the conclusion, Kepler's second law relates the speed of the motion of a planet to the distance from the Sun. This is because of the elliptical orbits, and in consequences, the distance from the Sun varies depending on the position of the planet in certain moment. It also states that if a line is drawn from the Sun to a planet, and this will be the radius of the elliptical orbit, the area swept by that line in a certain time will become a constant. This means that when the planet is farthest from the Sun, it will move much more slowly than when it is closer to the Sun, and this law is basically a statement of the principle of conservation of angular momentum for planets.